Hi guys, hi everyone and welcome to today's live stream. Sorry for starting a little bit late, but today we are looking at volume, and so I've got my special isometric paper here. 1 second, sorry, let me just sort that out. Just seeing if this is working. It doesn't seem to have started yet. Let's see if that's going on. Perfect. Just check. Perfect. Sound check is done, so that is all good. Okay, great. Right, so hi everyone. I'm Ian from Crack Maths, and today we are looking. I've been looking at loads of different topics for functional skills over the past few weeks, but today we are looking specifically at volume. Okay, so in functional skills maths for level 2, there's a few volume formulas that you need to know, and then there's a lot of volume formulas that you are going to be given. But before we start on this, let's have a quick look at what volume is. So I've drawn here, I've got some isometric paper here. So what I'm going to do is if I draw this shape here, okay, this shape here is meant to be a cube, okay? So this shape has volume, okay? If we go to, 1 second, let me actually go to some squared paper. Here we go. In maths or in life, what we have is we have lengths, we have areas, and we have volumes, okay? A length is something that you're going to see, which is going to be just a distance, okay? So here we go, this would be a length, and the way that I would measure this would be in a unit of length. So for example, if I said that these squares are centimetres, I would say that this has a length of 1, 2, 3, 4, 5, 6. That has a length of 6 centimetres. Now an area, as we discussed the other day, is when something takes up space. Okay, so lengths don't really take up space, they're just long and thin. An area is something that takes up space. So say for example here, this shape takes up space, and I know that because I can colour it in, okay? So I can colour in this space. So here we go. And this space here would have a specific area, and the way that we can judge the area of a shape is by counting the squares inside. So I could say that here, this is 1, 2, 3, 4, 5, 6, 7, 8, 9. So I would say that the area of this is 9 centimetres squared. Okay? Right, now what I was doing on the other page is I was introducing you to volume. So volume is when we give our squares a third dimension, okay? And then they become, well, like everyday objects really. They become like the kind of things that we're gonna like handle in real life. So, and the third dimension is given to us such like this. So I'll draw it on here first, but the square paper is going to help. So what I would do here is I'm going to say that we've got, here we go, we're going to have it such like this. So now, in theory, this is a third dimension, and this dimension's made up by turning each of these squares into cubes, okay? So, and here now what we're talking about, when we talk about these, we are talking about volume, okay? Because what we've got here is we've got 3 rows, okay? So we've got a row of these green squares, then I'll put a different colour for this. We can have a row of these grey, a row of grey squares here, and then after that we could have another row of, let's make these squares orange, And I shouldn't be saying squares, I should be saying cubes, okay? Because in order to make these rows, we do need cubes, because we need something with a bit of depth to it. So if I have 9 cubes on the front, that makes up, well, if I have 9 squares on the front here, and I've turned them into cubes, I've got 9 cubes on this front row of this shape. Then here, on this grey level, here, I'm going to have another 9 centimetres cubed. And then on this orange level here, I'm going to have another 9 centimetres cubed. Okay? So what we can see here is we've got 9 centimetres cubed here. We've got 9 centimetres cubed on the second level. And we've got 9 centimetres cubed on the third level. And what this is what we're talking about when we're talking about volume. And I put squared there as well. So this is what we're looking at when we look at volume. So lengths, as we said, lengths are the flat ones. So lengths are straight and flat. Areas are spaces, like this. And cubes, well, volumes are when we have the third dimension. Okay, so something like this, as we've just drawn. Now, it doesn't actually matter what shape it is at the front, we can still get different volumes, okay? So if I had a circle at the front, I can still give my circle a third dimension here, okay? And we would still take the area in squares, even though with a circle it's not going to be the exact number of squares. And then we could still break this up all the way down. So we could still see how many rows of these squares, once they're turned into cubes, there are. Okay? And this takes us to the main formula that you need to know for volume in functional skills maths. And that main formula is this, okay? And it's volume of a prism, okay? So volume of a prism. And essentially a prism is any shape, any two-dimensional shape that is then stretched to be a three-dimensional shape. So let me draw some out. So we could have a rectangular prism, or what we'd also just known as a cuboid. So a rectangular prism starts off with looking like a rectangle, okay, and then we turn it into a three-dimensional shape by going backwards. Okay, so this is something like a brick. We could have a triangular prism. Okay, a triangular prism would start off like a triangle, and then we just add the third dimension so that we're going back. Okay, so this would be a triangular prism. A common shape that looks like this is a Toblerone. Now, if you snapped this shape, it'd be this all the way through. And then the other shape that we could have, that we're going to need to know how to work out, is, as I just said, a circular prism, which we also call a cylinder. Okay, so here we go, and that would be this all the way through, and this would be a circular prism. Okay, so we've got 1, 2, 3 shapes here that we're going to need to know how to find the volume of. Now, what we decide is it's easiest to understand this with the rectangular prism, because if I just go along here and divide this up, I can see basically this is going to be lots of, well, let's make it look a bit more realistic, lots of this, okay? So it's going to be these 6 cubes, which make up this front shape, as many times as you go back. So here, I've got 1, 2, 3, 4, 5, 6, okay? So the volume of this cuboid, or this rectangular prism, is going to be the number of cubes that make up the front face, multiplied by the number of rows of cubes that you have. Okay, so the way that we do, the formula that we have for volume of a prism is this. Volume of a prism equals the area of the face multiplied by the length. Okay, so here we go. The volume of a prism is the area of the face multiplied by the length. So we're going to have to, in this topic today, we're going to have to recall some of our formulas for area. Okay, but before we go on, let's just do one example of each one of these things. Okay, so first of all, let's look at the volume of a rectangular prism. This is also known as a cuboid. Okay, so let's say I have a rectangle at the front. So let's say my rectangle here is 3 by 4. Okay, and then let's say we're going to go back, and I'm just going to say that we're going to go back how many spaces? Let's say we've got 3 centimeters here, 4 centimeters here, and let's say we're going back 10 centimeters. So remember, the volume of a cube of any prism is you find out the area of the face and then you times it by how many times you're going back. So here I need to work out the area of this rectangle. Okay, so the area of this rectangle, if you need to remember, area of rectangle is equal to length times width. Okay, so in this case it's going to be 4 times 3. Okay, we've got that here. So we can see that that's going to be 12 centimeters squared. And now the volume of the prism is the area of face times the depth. Okay, so the area of the face here is the 4 times 3, which is the 12. So I can put that here, and then, so that's 12. Now, I'll put 12 centimeters squared there. It doesn't really matter in the calculation, but there we go. So the area of the face is the 12 centimeters squared, and the depth that I've got here is the 10 centimeters. Okay, now the 10 centimeters tells us that we're going to have 10 rows of this face. I don't know if that's 10, but here we go. We would see that if we were, it's almost like if you were slicing a loaf of bread. If we were slicing up the loaf of bread, we would have these 12 squares 10 times. So that's why we multiply them together. So we've got 12 times 10, which is going to equal 120 centimeters. Centimeters cubed. Okay, right. Let's have a look at the volume of a triangular prism. Okay, so remember, volume of a prism equals area of face times depth. Okay, so this time I'm going to get my triangle. So let's say I've got a triangle that looks like this here. So here we go. And then I'm going to give it some depth here. So the area of a triangle, have a think to see if you can remember it, because this is a formula that you need to know. So I'm just going to colour this in here. Okay, if you remembered it, the area of a triangle is going to equal base times height all divided by 2. And I'll use the line here for divided by 2. Okay, so what we've got here is this is the area of the triangle. So in this case, this area of triangle is the area of the face. So let's first of all work out what that area of the triangle is. So I can see that I've gone 3 squares along here. So I'm going to say that's 3 centimeters. So that's the base. The height is to the top of the tent, okay? and so that's also 3 in this case. So if I'm going to work out the area of this triangle is going to be 3 times 3, and then I'm going to divide that by 2. So the area of this triangle is going to equal 9 divided by 2, and let's do that on the calculator. So I'll move that over here. So 9 divided by 2, and that's going to equal 4.5. So the area of this triangle is 4.5. So although it's all broken up, these squares amount to 4.5 squares. So now remember, the volume of the prism is the area of the triangle times the depth. So let's give it a depth. Let's say we've got 1 layer, 2 layers, 3 layers, 4 layers, 5 layers, 6 layers. Okay, so I'm going to say this is 6 centimeters deep. Now, if you think about these triangle, the face being turned into cubes, we know that each layer here is going to take up 4.5 cubes. So let me just shade some of those in. So we've got 4.5 cubes in the front layer. 4.5 cubes in this layer. I'll leave that one blank. 4.5 in this one. 4.5 in this one. Each one of these has 4.5s. We've got 4.5 here, 4.5 here, 4.5 here, 4.5 here, 4.5 here, 4.5 here. And so what we can do is we can actually just do the area of the face, which is 4.5, times the depth, which is how many rows of these 4.5 cubes we have. Okay, and in this case it's 6. So the area of the face times the depth. So we've got 4.5 times 6, and that's something I'm going to do on my calculator. Oh, 1 second, let me move my calculator there because I've got in the way of what I was writing. So 4.5 times 6. Okay, and that equals 27. So the volume of this prism would be 27 centimeters cubed. Okay, right, now there's one more prism that we need to know, and that is the cylinder. Okay, so we've got here volume of cylinder. Well, it's volume of prism again, really, but a cylinder is just going to be a cylinder because it's going to have a circle on the front. So let me write that here. The volume of the, let me move this out of the way. Volume of the cylinder of prism. Remember, it's the area of the face times the depth. Okay, so here we go. In this case, we've got a circle, and we're turning it into a 3D object, well, a cylinder. So in this case, the face, the area of the face is going to be the area of the circle. Okay, and then the depth is always the same. It's how many rows of this we're going to have when we turn that area into cubes. So, have a think. Can you remember the formula for the area of a circle? I'll give you a moment. If you can, great. If not, don't worry, but it is one that you do need to know. So, area of circle equals pi times the radius squared. I'm just going to use r. Now remember, in functional skills maths, we always use 3.14. So this is going to be 3.14 times the radius squared. So let's say that this one here, it's got quite a small radius actually, but it looks like it's more than 1 square. So I'm going to say the radius in this circumstance is 1.2. So 1.2 squared. Now remember, squared means to times itself. So the area of this circle will be 3.14 times 1.2 times 1.2. Okay, so let's use the calculator to work out what that is. So I'll put that just down here. So we've got here 3.14 times 1.2 times 1.2. Okay, and that equals, right, let me move that up. So I'm just going to move that off my screen. So that move it up there for the time being. That equals 4.521 6. Okay? So that means if I was to divide this front section into squares, there's 4.5126 squares in that front section. Now, when I turn it into a volume, I'm turning it into something that takes up space. So I'm going back and I'm turning all of these into cubes, okay? So that's what's happening here. So we know that each layer of this cylinder, okay, let me colour that bit in here to show you what the layer is. Each layer of this cylinder is going to be 4.5216 centimetres cubed. Now, how many layers do I have? I've got one layer at the front, I've got a second layer here, I've got a third layer here, I've got a fourth layer here, I've got a fifth layer here. So I've got 5 layers of 4.5216 centimetres cubed. So I've got the area of the circle here. So that's what I've been talking about. That's this 4.5216 centimetres cubed. And then I've got the depth here. Okay, and the depth I can see from this bit here. Ooh. The depth I can see from this bit here, I can see I've got 5. So the depth is 5. So for the volume of this prism, I'm going to do 4.5216 times 5. Okay, so let me get that done. So here we go. We've got 4.216 times 5. And that is going to equal 21.08 centimetres cubed. And that will be the volume of that shape. Okay, right. One key thing that we also need to remember with volumes is volume questions always link to liquids. Well, they don't always link to liquids, but they often link to liquids. Now, we end up calculating our measurements often in centimetres cubed. Okay, but you'll notice from when you buy bottles of drink and stuff that volumes of liquid are often given to you in millilitres. So we need to know that 1 centimetre cubed equals 1 millilitre, okay? So that's just a common thing that we have to know. Right, okay, so what I want us to do now is to hop on over and I'm going to have a look at some exam style questions all to do with volume. So let me see. Here we go. Let's have a look at what we've got. Switch that to landscape. Right, so here we go. We've got a question here, which is a volume question. So let's have a quick read through this to see what we think. So the question says, Matt buys a new fish tank. The fish tank is in the shape of a cuboid, okay? So remember, a cuboid is just a rectangular prism, okay? The fish tank is in the shape of a cuboid. The diagram shows the water in the tank. Matt knows that 1,000 centimetres cubed equals 1 litre. He also knows that 1 gallon is 4.5 litres. And he also knows that he can keep 2 small fish in the tank for every 1 gallon of water in the tank. Matt thinks he can keep more than 36 small fish in the tank. Is he correct? Right, okay, so we're going to have to just take a quick moment to think about what's going on here. So let's just have a think. I'll just leave you to do that for a second. Okay, so have a quick think about what you're going to want to do. Okay, well, let's get started. Now, I would say one of the main things to think about with these sorts of questions is firstly to always consider the units that they're giving you. So here I have all of this stuff is in centimetres, and this is in centimetres. So actually, this question is all right. The units that they want to know are in centimetres, and they've given us the conversion for volume in centimetres cubed. So for this question, the units are currently okay. So what we first of all need to do is we need to find out the volume of this cuboid, or this rectangular prism. So remember, what we can do is we can find out the area of the face, okay, and multiply it by the depth. So the area of a rectangle is length times width, so I'm going to do 30 times 100. Now remember, with numbers that end in zeros, you can just times the non-zero numbers together and then add the zeros on afterwards. So 3 times 1 is 3, and then we can add 3 zeros. Okay, so the area of the face is 3,000 centimetres squared. Now remember, the volume of the prism is area of face times depth. Okay, so the depth here is this measurement, so that's 30 centimetres. So we know that the area of this is 3,000 centimetres, and so we've got 30 layers of those 3,000 centimetres cubed. So we now need to do 30 times 3,000. And remember, we can times the numbers at the front together first. So 3 times 3 is 9. And now we can add on the 4 zeros. Okay, so here we go. We know that the volume of this fish tank, or the water in this tank, is 90,000 centimetres cubed. 90,000 centimetres cubed. Okay, right. If we know this, we now need to convert this into litres. We've been told that 1,000 centimetres cubed equals 1 litre. So we've got 90,000, okay? So 1,000 cm cubed equals 1 litre. We have 90,000 centimetres cubed. So what we need to do, we can actually hear that when we think about it. So we want to go from 1,000 to 90,000. And that is actually 90 lots of 1,000, okay? And you can kind of hear it if you really think, if you listen to it. 1,000, 90,000. So that means that this is going to be 90 litres, okay? So the volume of this tank will be 90 litres. Right. So now we've got the fish tank is 90 litres, okay? So I'll just put that there. We know this is 90 litres. Now, what we find here is we've currently then got gallons at play. So we're told that 1 gallon is 4.5 litres. Now, I'm going to tackle this by doing something here which I've spotted is a connection. So if I know that 1 gallon equals 4.5 litres, the trick to this question is going to be you spotting that 4.5 litres is half of 9 litres. Okay, this is how this is going to be okay. So if I've got here 1 gallon is 4.5 litres, I know that 2 gallons will equal 9 litres. Okay, now if I know that 2 gallons is 9 litres, I know that 20 gallons is going to equal 90 litres. So, if I've got there that 20 gallons is 90 litres, from this, what I can do is I can identify that this fish tank holds 20 gallons. Okay, now let's look at this next part of this question. He can keep 2 small fish in the tank for every 1 gallon of water. Okay, so in 1 gallon, he has 2 fish. So let's see about what that will be for 20 gallons. Okay, so he has this then 20 times. So 1 times 20 is 20, 2 times 20 is 40. So therefore 20 gallons is enough water to hold 40 fish. 20 gallons is 40 fish. Okay, great. So that is actually the question pretty much done. Matt thinks he can keep 36 small fish. Well, actually he's able to keep 40 fish. So we can say, yes, Matt is correct. Okay, great. Right. Let's now have a look at another question. Let's see if I can find a question actually which has a cylinder. Okay, so I think that would be nice. And let's have a look. Although cylinders are almost always tins of paint. Here we go. Here's a question that looks like a cylinder. Okay, right. So, here we go. This is in the calculator section again now, so we can feel safe knowing that we've got our calculator back. Right, so let's have a quick read of this question, and then we can have a look at how to answer it. So, a tin of carrots is a cylinder with a radius of 2.8 centimetres and a height of 9 centimetres. When filled, 1/6 of the volume of the tin of carrots is water. The company uses 425 litres of water each day in tins of carrots. 1 litre equals 1,000 centimetres cubed. How many tins of carrots does the company make each day? Oh, right. Okay. So there's a lot going on there. But I think the first thing we should probably do is just find out the volume of the cylinder. So remember, a cylinder is a prism. So the volume of the cylinder is always going to be area of face times depth, or in this case, height. Okay, now remember, because this is a cylinder, we need to know the formula for the area of a circle. So we've got here area of circle, and that's going to equal pi times the radius squared. Now remember, in functional skills maths, we always use pi is equal to 3.14. So I'm going to do that this is going to be 3.14, and they've given us the radius, 2.8 times 2.8. So here we go. I can get my calculator out, and get the calculator, and then I can solve this from here. Okay, so let's have a look. We've got 3.14 multiplied by 2.8 multiplied by 2.8. Okay, and so this equals 24.6176. So that is the area. So we've got the area here, so that's the green bit. Now remember, to find the volume, we've got to multiply this by the height. So I now need to do this thing here. I need to do my 2, oh, that's not a 2, that's a 3, and that's a 4. I need to do my 24.6176 multiplied by 9, and that will give me the volume. Okay, so if I times this, I've got it on my calculator already, times this by 9. So here we go, the volume of the tin is going to be 221.5584 centimetres cubed. So remember, that is if we had this 9 times and we turned all these into cubes. So that's how many cubes it would take going down. Okay, let me remove that drawing. Right, okay, so we now have the volume of the cube, of the cylinder. Now, in the question I can see it says here that 1/6 of the volume is filled with water. Okay, so this is the volume of the whole tin, and I want 1/6. Okay, so 1/6. So 1/6 means it means a sixth of the shape. So basically, if I wanted a sixth of this, I think about this: 1, 2, 3, 4, 5, 6. So basically, I just want one of these bits. Okay. So what I need to do to find a sixth, you need to divide your answer by 6. Okay. So if I want 1/6 of this, I need to do 2 to 1.5584 divided by 6. Luckily, this number's already on the calculator, so I can then just press divide by 6. And this equals 36.9264 centimetres cubed. Right. Whew. Okay, so we're about halfway through this question now. So we know that we've got here that 1/6 of the tin, 1/6 of the volume of this tin is 36.9264 centimetres cubed. Okay, so we know the company uses 425 litres of water every day. Right, so we know that 1 litre is 1,000 centimetres cubed. Let me just show you that there. So we've got here 1 litre is 1,000 centimetres cubed. So if 1 litre equals 1,000 centimetres cubed, then 425 litres is going to be this times 425. So that's actually going to be 425,000 centimetres cubed. Now, I know that is how much water they're using every day. I know that this is the volume of the tins. So I know that volume of tins, volume, times the number of tins, equals, so volume of water times number of tins will equal 425,000 centimetres cubed. So what I can do is I can just put the information that I have and then work it out from here. So we know that 36.9264 times the number of tins has to equal this 425,000. Okay, now, in order to find out the number of tins, I need to remember my reverse calculation in order to do that. And that is going to be that if two numbers multiplied together to make a third number, then this third number divided by one of these two numbers gives us the other thing. So 425,000 divided by 36.9264, that's going to give us the number of tins that they produce each day. So let's have a look at that. So I can't use that unfortunately because it's the wrong way around. 425,123 divided by 36.9264. What's this going to equal? This is going to equal 11,509.38 tins, okay, which I'm going to round down to 11,509. Okay, and I'll put tins there as well. Right. Okay, well, if you followed that, well done. Thank you very much for joining me. I will be back on Monday for another live session at 4 o'clock. Yeah, thank you so much, and hopefully see you again soon. If you do, by the way, if you do need more work on practicing volume and volume of different shapes, volume of prisms, or using volume formulas, there's plenty of work over on crackmaths.co.uk. I have put a link to my YouTube playlist as well, covering different types of volume questions as well. So thank you very much, and yes, hopefully see you again soon. Cheers, bye.